Okay everyone, this is the unboxing for the Swift Arduino Silver box. So as before, this is a box that contains an Arduino compatible with the Grove system in it. When we open this up, you'll see in here we've got three components. The LED that's in the bronze box has been replaced by a 10 strip Neopixel strip, which is much more fun to work with. It's got lots more options on it. Each of these 10 pixels can be controlled with an RGB value from 0 to 256 on each of the three channels. We've got a temperature sensor here that gives us basic temperature and humidity, and we've got the standard button plus the three leads. I've hooked this one up just because it makes the demo an awful lot quicker. And I'll just pop this on here and you can see me plugging the parts in. So as before, if you've seen the demo for the bronze, the Grove have these nifty little leads, and you just hook your component in like this. So it just goes straight in there. So I'll put in the Neopixel lead like that, and I'll pop that in. I'm going to put that in on pin 4, so you can see D4 there. Just plug it straight in. No wires, no soldering. Plug it straight in, nice and easy. And as before, I'm going to put a button in there, and I'll pop that into pin 7. So you've got pin 7 is pulled out here by this Grove socket. And now I'll show you the reasons that I chose those particular values. If you come up here, you can see the example program we got for the S4A Elements Silver package. If we pull that open, this is very similar to the one for the bronze package. We've got the pins defined up here as constants, the ILED pin, which is the pin that powers these Neopixels, and they've got a very simple idea. They've got a one-wire protocol that transmits all the data down in a short burst, and it's quite tuned. So we've got some tune code written into the base libraries within Swift Arduino, so that's all done for you. And we've got an extra library here that we're using just to make life a little bit easier for ourselves. So all you really have to do is define the number of pixels, and here we've got it defined as 10. Define the pin that the button that the ILED is being driven by, which is pin 4, and then we've defined the button pin as 7 here. And as before, we've defined this as an output pin and the button as an input pin, as you'd expect. And this is very much the same sort of code that you would see in the fade sketches and in the bronze package. The difference being that now we write out to the Neopixel stick, and we're writing basically the same red value out 10 times, with green and blue being 0, white being 0, and down here it's all the same code, which is basically fades in and out, and the buffer is set up at the top. If I upload this, okay, we're going to see that go through. Now you can see we've got a nice fade in and out using a 30 millisecond delay, and as before with the bronze sketch, if I hold down the button, fast pulses, and look at that, that's an absolutely lovely colour. You could put that into a device, one that's hidden behind something. It'll give a powerful light but a smooth fade in and out, and all of those levels are being done at an absolutely precise rate using pulse width modulation. So it's just completely qualitatively different from the sort of thing that you'd get if you drove it directly from a Pi or something like that. This is how you make devices, and as you can see, we've done this with 3 minutes. Okay, and that's everything. Thanks.